A buffer is referred to as an aqueous solution that has a very stable pH value. A buffer is combined of equal parts of a very weak acid and a weak base in large combinations. A buffer works by neutralizing the acid or the base that is combined with the solution. A buffer resists pH change. An example of a buffer is present in soda. There's a buffer in the drink to keep the acid in the drink from eating away at your teeth. CH3COOH, which is commonly referred to as acetic acid, is a weak acid. It is added to water and it dissociates into its conjugate base of CH3COO-, which is acetate, and a hydrogen ion. For my example, I'm going to show you how the values of Ka and H+ are equal in a buffer solution. To make 1 molarity of CH3COOH a buffer, the conjugate acid needs to be increased. This can be done by adding sodium acetate to the combination. So you would replace the H with Na, and the sodium acetate, which is now this, will dissociate completely. For my example, I made a rice table. This is the reaction, and this is the initial concentration of each. So you have 1 molarity of acetic acid and 1 molarity of acetate, and you have no H+. So the change, we're not sure what the exact concentration change is, so that's why it's just present in an X. And then this shows how the initial is present with the change. For the next step, you're going to need to know that the equilibrium formula, this, and that Ka equals 1.76 times 10 to the negative 5. For my example, you just input CKa, you just input that right there, and then the CH3COO-, which is right there, you just implement that right there, and you just fill it in. And since you have a plus X right there and a minus X, they'll just cross out, so they basically mean nothing. So you just have 1/1 to the X. So since it was a 1/1, that just means that X is equal to 1.76 times 10 to the negative 5. So that shows that X is equal to pH of acetic acid is 4.754, and since it's a buffer, it's a very stable pH value.